This lesson is on literal equations. A literal equation is an equation with two or more variables. So a literal equation, think of as a formula. It has more than one variable, and when we are using a formula, sometimes we want to solve for a particular variable in that formula. For instance, number 1, solve for f. So the formula we have in number 1 is C equals 5/9 times the quantity f minus 32. This is the formula to take a Fahrenheit temperature and convert it to Celsius. If we know the Fahrenheit temperature, we can just plug it in right here to the formula and it'll output the Celsius. But what if we knew the Celsius and we wanted to convert it to Fahrenheit? And so we had a whole list of them. Well, if we solved for F, isolated the Fahrenheit, then we could plug in the Celsius numbers, temperatures, and we would easily get a Fahrenheit number. So we're going to solve for F. Alright, so we're going to solve for F. So we need to undo all these operations, take the inverse. First of all, it's multiplied by 5/9 and it's got 32 subtracted from it. Since these are in parentheses, we first need to isolate this. So we need to get rid of the 5/9. So if we multiply each side by the reciprocal, 9/5, 9/5, that would give me 9/5 C on the left is equal to, well, 5 over 9 times 9 over 5 is 1, is equal to F minus 32. Trying to isolate F, I have the 32 subtracted from it, so I just add 32 to both sides. So on that left side, we have 9/5 C plus 32 equals F. So I have solved this little equation for F. So now if I had Celsius readings, temperature readings, I could easily plug it into the formula to get the Fahrenheit. Okay, the next one is C equals 2 pi r. We recognize that formula. Circumference equals 2 times pi times the radius. We want to solve for r. So in this instance, the way it's set up now, if I knew the radius, I could just plug it in and it would give me the circumference. But let's say I want to know what the radius is. I know the circumference, so I need to isolate r. So r is multiplied by 2 pi, so if we divide each side by 2 pi, the circumference divided by 2 pi is the radius. So now I have a formula. Given circumference, I can calculate the radius. Alright, so we can apply this to all types of equations. So here we have a ax minus bx equals c. We want to solve for x. Alright, we have an x in this term and an x in that term. We need to isolate the x. So we can look at ax and bx. They have a common factor of x, meaning I can divide x into both of those. So I'm going to factor out the x. Or think of it as undoing the distributive property. So let's distribute for a minute. X times a is ax. X times b is bx. So I'm just undoing the distributive property, and that has isolated my x here, because now I have x times this term of a minus b. So to get rid of that, to isolate x, I just have to divide by a minus b. X equals c divided by a minus b. And we know this should be number 3, and this should be number 4. Okay? Solve for y. We want to isolate y. Negative 3y plus 2x equals 5. We'll be solving for y a lot in Algebra 1, so this is one of the reasons we learned how to use the literal equations. Alright, so we're going to be solving for y. So I have a plus 2x added to it, so I'm going to have minus 2x. I have a negative 3y equals 5 minus 2x. I want to isolate y. It's multiplied by a negative 3, so let's divide each term. Everybody gets divided by negative 3. So that leaves me y equals, I have 5 divided by negative 3. I'm just going to write it as negative 5/3. A negative 2x divided by a negative 3, well, these two negatives make a positive. So it's plus 2/3. Oops. Plus a 2/3 x. So now I've rewritten this formula. Given an x value, I can easily plug it in to get the y. And that's how you solve literal equations.